IDTechEx 2015 USA is over right now. So how was the experience for you?
Yeah, it was a very exciting conference. We have, a broad selection of topics. We have had very good feedback from the conference. For example, we had a session on next generation battery technologies in which we had some of the most interesting companies presenting the next generation of batteries, including lithium sulfur, solid state batteries, and progression on silicon anode batteries. And there was a broad discussion about the applications of these technologies and what is the role in both different segments such as consumer electronics, wearable electronics, automotive, and some other electric vehicle emerging segments such as UAVs and infrastructure. So I think as well the aim of our conference in many technology verticals has been accomplished, and we have received good feedback, and many people will come to our next conference, and some of them will go to Berlin.
What's the main advantage of going from lithium-ion to something else? What do people want to do that?
Basically, what has been preventing the kickstart of some of the new technologies in consumer electronics, for example, I'm speaking about wearable electronics, is that the energy density of batteries is not enough to make them really portable and wearable. So there's a need to downsize the size of the cells and at the same time increase the energy density. So these devices can be really portable. On the other hand, in electric vehicles, as you know, there's a limit of about what can a lithium-ion battery provide in energy density, around 250 watt-hours per kilogram. So lithium-ion will only improve its performance in an incremental way, but then we need to develop new technologies that can disrupt and increase that performance in a more dramatic way, in order to have widespread diffusion of electric vehicles, have new segments being more broadly adopted, such as residential energy storage and so on. So,
is there some battery technology that's going to just by an order of magnitude increase battery life on smartphones?
Well,
or is that not going to happen?
I wouldn't say that it's only one technology. There's a group of different technologies, including lithium sulfur batteries, lithium silicon anode batteries, and solid state electrolytes integrated in batteries. So these three technologies have very interesting potential to increase dramatically the lifetime of consumer electronics.
In one of your presentations, you were talking about magnesium. What's good about that?
Magnesium is a technology that is it has double volumetric energy density than lithium-ion, and has a very high potential, such as other technologies such as lithium air. Unfortunately, these technologies haven't had the technology development required to progress to commercialization. So we won't see these technologies commercially in the next following 10 years.
But why can't we get new battery technology like next year and 3 months later? Why does it take so long sometimes to get stuff?
Well, there are a set of challenges. It's not just having the breakthrough in a lab in what is required to have a battery next year. What you need is there are engineering challenges, such as increasing the size of the cell at manufacturing level and keeping the same performance. As you increase, everybody knows that as you increase the size of the cell, there's more risk of quality issues. So those are engineering challenges. At the same time, companies need to overcome different commercial and financial challenges, such as getting funding, having a revenue from other niche segments, so they can have a escalation of their manufacturing along the medium and the long term.
But if somebody has a lot of money, like $1 billion or something, they can just make it happen in 6 months, some of it?
Well,
or is it like because there's unknowns and the science is not made yet?
There are some technological challenges still. Of course, that funding will accelerate the research of many of these companies. And many of these companies are receiving funding and doing partnerships with other larger companies. But this is a process, and I think that, well, the challenges of engineering shouldn't be underestimated.
All right. And but the Moore's law is not going as fast with batteries, right? Or is it only happening for the number of cycles that recharge can be done on the batteries? Because the Moore's law is going very fast with CPU and everything, but the battery is not keeping up. The battery life is still kind of like not very good on smartphones, or?
Yeah, that's one important point is is many of these technologies will offer like new possibilities to mobile phones and so on, and they will offer like a higher number of cycles, for example, and in that way they will be able to be adopted.